All right, guys, so we're going to start looking at a couple of ways that you can do simulations using random table of digits, which you can see right here on the first example, as well as examples where you use a random number generator on your calculator. We kind of have to know how to do both. So look at this first example. You'll see that it's from your notes, but we're going to do it a different way than we're going to do it in the notes. So you guys can see here it says at a local high school, 95 students have permission to park on campus. Each month, the student council holds a golden ticket parking lottery at a school assembly. The two lucky winners are given reserved parking spots next to the school's main entrance. Last month, the winning tickets were drawn by a student council member from the AP Stats class. So the person who actually physically did the drawing was an AP Stats. When both golden tickets went to members of the same class, so both golden tickets went to AP Stats students, some people thought the lottery had been rigged. I think we would probably think the same thing. If a stats student goes up and they draw it and they pick two stats kids, that kind of feels weird, right? There's our rare event that took place, and we're going to see how rare that actually was. There are 28 students in the AP Stats class, all of whom are eligible to park on campus. So design and carry out a simulation to decide whether it's plausible that the lottery was carried out fairly. Okay, so what we have to do is we have to simulate, right here at the top, you guys can see in my handwriting, we need to simulate picking those two students from the 95. A couple things we got to keep in mind. So we're going to pick two kids. We're going to pick them from the 95 total kids we have. A couple things we need to keep in mind. You guys can see it right here. We need to keep in mind that the probability of selecting the first stats student needs to be 98 out of 95. Right? The first time we pick somebody, the chance of it being a stats kid, 98 out of 95. Now, if the first kid is a stats kid, the second kid, that probability of picking that second kid should drop to 98 out of 94, right? So we're going to keep that in mind. It's going to come up here in a few minutes when we look at that second question, or that first question you guys see there about are we okay with repeating numbers? Okay, so the first thing we have to think about though is how in the world are we going to use this table of digits? How are we going to think about picking two students, and we have to ensure that the chance of a stats student is 28 out of 95 at first? Okay. The first thing we're going to look at doing is we're going to look at two-digit numbers. That's the easiest way. So you can begin by thinking about every two-digit number that you can create. The first way you can think about it is going from 0, 1, like 0, 2, 0, 3, all the way up to 99, and then after that, 0, 0. And in this case, 0, 0 kind of represents 100. Okay, so in this case, like you have like numbers 1 to 100 covered, right? So this is kind of a way of equating to around like 100%. Okay, you can do this another way too. You can also start at 0, 0, go 0, 1, 0, 2, all the way up to like 98, 99. And in this case, this would represent like 0%, I guess, but 0% going up to like 99%. This one's kind of funky because technically you have numbers here 0 to 99, but there's a total of 100 numbers in that list. So because there's a total of 100 numbers, it still acts like it's 100%. Okay, so that's kind of why we begin there. Okay, so the reason I talk about this is because this idea right here of adding up to 100%, we may not use it on this problem, but you can use it on other problems. So if you're trying to think about taking 100% and divvying it up across different groups, you can do that. In our case, we actually are going to let our two-digit numbers represent actual students. So in our case, instead of thinking about going all the way from like 1 to 99, we're going to change this up a little bit. We, in this case, will just care about thinking about 1 to 95. Okay? In this case, 1 to 95 will be assigned to each student. Ooh, come on. So the number 1 gets assigned to the first driver, the number 2 gets assigned to the second driver, and so on. But you might be thinking about what about 96, 97, 98, 99, and 00, 0? In this case, we're going to say that we are going to ignore 96 through 00, 0. Okay, in this case, we're going to disregard them. We do not care about 96 through 00. In other problems, if you are going to do something with percentages, like you need it to add up to 100%, then we can keep that 96 through 00 in the problem. Okay, all right, so if we let 101, like you can see here, 01 through 95, if we let those represent our students, now we have to kind of represent this idea of 28 of them being AP Stats students. So from our 01 to 95, we're going to assign 01 to 28 to AP Stats students. Okay. Something we're going to double check is we're going to make sure that 01 through 28 counts as a total of 28 numbers. So in this case, it's very easy. 01 to 28 is definitely 28 unique numbers. That means that we're going to make 29 through 95 non-AP Stats students. Okay, so what this takes care of is this part up here where I said the probability of selecting the first stat student needs to be 28 out of 95. So by us going right here and making 01 to 28 those AP Stat students, there's 28 numbers there out of 95 total. That takes care of that for us. Okay. All right. Now, how do we actually use it? Okay. So when we go to our table of digits, what we're going to do is we're going to move, well, first of all, we're going to start on this top line up here. And we're going to look at every 2-digit number moving left to right. So at first, the first number I see is 61. Okay. So in that case, that would be a non-stat student. The next number we see is 42, so right there is a non-stat student. So neither one of those numbers represent stat students. Remember, we're trying to simulate picking 2 students. So 61 and 42, that's me picking my 2 students. This actually, I kind of like to draw like a bar in the middle. This represents a simulation. So this right here is actually like simulation number 1. The first simulation is done. Okay, and then we would go on to the next simulation. So we would go over here, we would see 4, 2, and 04, and that would be the end of a simulation. So this time we get, this is like simulation number 2, and this time we get 1 stat student is selected. We keep rolling, we have a 19 and 86. So in this case, again, 1 stat student is selected. We have a 5, 6, and a 6, 0. That's the end of the simulation. We have 2 non-stat students picked. Here we have an 05 and a 17. In that case, they are both stat students. Okay. So also, if I want to keep going, which you'd want to do this many, many times, you would want to roll down. If I get my highlighter out real quick, you would want to continue this, moving down into like this next, oh, that didn't come out very good. Let me see if I do it another way. I would want to roll down here and begin here at the next row. So you move left and right down a row and then just move to the next one. So the next one we looked at would be like 9, 0, and then 2, 2. Okay. All right, that's how you use the table. Something we need to consider is this next question. Are we okay with repeats? Okay, so for example, if we get somewhere in the row, and let's say I pull numbers 6, 4, and 6, 4, am I okay with those repeating numbers? In this case, the answer would be no. Okay, in this case, the numbers represent students. The numbers represent unique students. Okay, so like if I pick 64 and 64, that's like I picked the same kid twice in the simulation. So in this case, when you're writing out your steps and you're designing that simulation, you want to make sure that you say, we're going to look at every 2-digit number moving left to right. We want to make sure that the numbers are unique, or you could say we want non-repeating numbers. Just make sure to include that in your description. Okay. Something else you want to include is you want to make sure that you know what you're actually counting. So like I just showed you guys how we use this table, but the question is, what do we actually care about? What do we want to count? So keep in mind what the rare part of this problem was. The rare part of the problem is back up here where it says, oh, ignore that. Go away. Where it says, where does it say it? Both tickets went to members of the same class. So we care about when both tickets go to stats students. So somewhere on your paper, you want to keep track, like maybe in the corner down here, you want to keep a tally system, and you want to keep track of how many simulations you've done and how many of them resulted in both students being selected in AP Stats. So remember, I think I said in class that we would like to see no fewer than 20 simulations. So let's say this is a suggested assignment, and let's say it said do 20 simulations. Okay. Well, so far, if I look at my table, I've done 1, 2, 3, 4, 5. So I have 5 simulations done, and out of those 5, so far only 1 resulted in both students being in AP Stats. That's what we care about. Okay, so maybe I keep going, I complete my 20 simulations, and down here, just for the purpose of right now, just keep like a little tally system for yourself, see how many result in that. And remember, when you are trying to calculate your probability at the end to see how rare it actually is, for this example, maybe it ends up being 7 out of 20 as your probability, and then you can go on and kind of justify with that, okay? But that's how we use a table of random digits, okay? Usually what we're going to do is look at 2-digit numbers, and like again, I just want to point that out. Let me go back to my little highlighter. I just want to draw attention to this. 2-digit numbers right here. In this case, we went 01 to 95 because the numbers represent actual people. Sometimes you might want to go 01 to 00 or 00 to 99 if you are working with percentages, okay? With that in mind, let's look at this problem. Oh, let me put this away. See if it'll let me go. Come on. Okay. All right, this one's different. Okay, so this one says a basketball player claims to make 38% of her 3-point shots. Simulate her next 10 3-point shots using a random number generator. So here's where things are gonna be different. We're gonna talk about your actual TI-84 this time. So we're not using a table of random digits. We're gonna talk about using your calculator, okay? All right, so this time, we're gonna simulate 10 total shots. Every time she shoots the ball, remember, we always have to remember that whatever the claim is, we are going to try to believe that. We're going to assume that that's true. So every time she shoots the ball, we're going to try to remember this 38%. So the probability of her making that shot should always be 38%. We never want that to change, okay? That's going to play a little bit when we talk about the next question about do we want repeating numbers, okay? Now here's what's really cool. If you guys look down here, I have some screenshots from your calculator. So the newest color edition, but the older one should be similar, okay? To get to what we're going to be talking about, you're going to use math, the math button on your main screen. You're going to scroll over here where it says probability, and you're going to find number 5 where it says rand_int. Okay, rand_int stands for random integer. Just a reminder, integers are numbers like 1, 2, 3, 4, 5. Technically the negatives too. We don't need the negatives, okay? When you open up that option, you should see this menu right here. And we're gonna be talking about what the lower bound is, the upper bound, and what n is. Just so you guys know, n is going to be the number, the number of integers you want to select. More on that in a second. You'll press paste, and then you should see something like this on your screen at first. After you click enter, you would see something like this, okay? So for example, in this case, they set the lower bound, technically this screen before it is wrong, they set the lower bound as 1, they set the upper bound as it looks like 8, and they told it to select 6 numbers. So right here, all of these numbers that were randomly selected are in the range of 1 to 8, and they wanted 6 total unique numbers. So 1, 2, 3, 4, 5, 6 total numbers. Okay, that's kind of how that works. Okay, how does that help us? Okay, we've got to simulate 10 shots. Okay, that's the big thing. Now, every time we have to keep in mind that there's a 38% chance of her making the shot. Okay, so kind of like last time, we want to think about numbers that kind of take care of that. So we're going to think about almost like the 2-digit numbers of the table of digits, but this time we don't really care if it is a 2-digit number. So for example, what we need to do is look at 100 possible numbers. So we can look at numbers like 1 to 100. Okay, so that's a total of 100 numbers, like actual numbers, which gives us 100%. Okay, this is similar to when we look at the table of 2-digit numbers, like up here. This is really similar to us using, This is similar to us using on the table, us using like 01 to 00. It's similar to that, okay? But we don't need to think about it for our calculator. The calculator is really cool. It can do a lot more than that. So on the calculator, we're going to let the number 1 through 100 kind of correspond to percents this time. We need 38 of those percents to be her making a shot. So we are going to let the number 1 through 38 represent her making it. Okay. And then we're going to let 39 to 100 represent her missing it. Okay. So what we have to double check is when I think about this, there are 38 total numbers out of a total of 100. There's my 38%. Okay. In this case, these would be all of my remaining numbers. So what, 62 total numbers out of 100. So a 62% chance she misses. Okay. Now, every time she shoots the ball, we have to maintain this 38%. Okay. So we definitely want to be thinking about the numbers 1 to 100. And what we would really like it to do is to generate a bunch of numbers, somewhere between 1 and 100. And every time we see one of those numbers, it's going to represent her shooting the ball. Now, how many do we want in total? We need 10 in total. Okay, so what you're going to do on this menu on your calculator is you're going to set 1 as your lower bound. We're going to set 100 as your upper bound. And we're going to make it spit out 10 numbers. This is your N. Okay, so on your screen you should see rand, int, 1, 100, 10 in this case. Okay, now it's going to spit out a bunch of numbers. I'm going to make some up for right now. Let's say it spits out 56, 21, 18, 3, 1, 19, I don't know, 78, and so on. Okay, let's talk about each one. This 58, oh, whoopsies. This 58, 50, oh, I can't even read. 56. That 56 is going to represent a missed shot, right? So 56, she misses it. Okay, next up we've got 21. 21 falls in the 1 to 38 range, so that means she made that shot. 18, she made that shot. 3, she made that shot. 1, she made it. 19, she made it. 78, she missed it. Okay, and so on. That's what that would represent. And again, you're going to count. What we care about in this case is her making shots. So out of your 10 total numbers, you're going to put the number of shots up top that she made. And that's going to help you do your probability. Okay. Let's go back to this question really quickly about do we want repeating numbers, okay? To connect it back to what we talked about earlier, the previous question, are we okay with repeating numbers? In that case, the numbers represented actual people, okay? In this case, the numbers we're picking represent percentages. So in this case, we're okay with that. So the answer to this one, do we want repeating numbers? Yes, that's okay with us. Okay, so you can say that when you set this up in your writing, you're allowed to say, in this case, we're going to use a random number generator. 1 is my lower bound, 38 or 100 as my upper bound, 10 as my N value, and we're going to let it select 10 numbers allowing repeats. You want to say something like that. So the rule of thumb that we'll kind of write down, okay, as far as repeats go, okay, do we want repeats? We're going to say no if the number represents a unique person or item. Okay. Do we want repeats? Yes, we want that sometimes if the number represents a percentage of some kind. Okay. All right, I know that was long, but that should kind of help you out doing some homework problems, helping you do tables of random digits like you guys can see here, and using a random number generator like you can see here.